Hello everyone, welcome back to Math with Allison. Today we're continuing our series on derivatives. If you haven't already, make sure to check out some of my previous videos. Click that little eye in the corner and it'll get you there. Otherwise, today we are talking about the quotient rule and how we can apply it and use it. So let's go ahead and dive into it. We are not doing the limit definition with quotient rule today. As we know that the rules here are used so we don't have to go through the whole limit definition. So yes, it's a bit of memorization, but yes, it's also a huge shortcut. So I just have the quotient rule written out here. So in the numerator, we have our function f of x, and in the denominator, we have a function g of x. So how we use quotient rule is we take the bottom and we multiply it by the derivative of the top, and then actually we need to subtract the numerator and we have to multiply that by the derivative of the bottom. And then all of this is all over the bottom squared, raised to the power of 2. So if we did the limit definition, we would find that we would get a function exactly like this, but we're going to save our time and sanity, so we're not going to do that. So how we can do this without having to do straight memorization, we're going to try that with the first problem here. So I'm going to zoom in a bit. So we have f of x equals e to the negative x. And if we look at this, we're thinking, well, this isn't even a fraction. Why are we looking at this problem? And it's because we can rewrite it as a fraction. So this can be rewritten as 1 over e to the power of x because of that negative exponent. So now here I can see I have a function in my numerator, which is equal to 1, and I have a function in my denominator. I'm going to go ahead and write those out. So this is a very similar setup to the product rule, right? So I label my numerator as f of x and I label my denominator as g of x. I can see the two different functions here. And what I want to do is I want to take the derivative of both of these. So the derivative of f of x is going to be 0. The derivative of a constant is always 0. And then the derivative of e to the x is just itself. It's e to the power of x. It doesn't change at all. So we have a specific order here when finding the actual derivative. So here I'm going to write f prime of x equals, and now we have to take our order. So we start at the bottom and we work our way up to the top. So here I'm going to multiply 0 times e to the power of x. And then there's always a minus in between. And now we start at the top and we work our way to the bottom. So it's a bit opposite of what we've been doing, but it still works. So here I have 1 times e to the power of x, and then all of this is going to be divided by e to the x squared. So let me go ahead and simplify this out. 0 times e to the x is just 0. So here in the numerator, we have negative e to the power of x divided by e to the x squared. And one of these e to the x's can actually divide out. And so here we're left with a negative 1 in the numerator and e to the power of x in the denominator. If we wanted to write it so it's similar to the original function, this could be rewritten as negative e to the negative x if I move that e to the x up. So that's how we can use quotient rule. Let's see another example here with a bit bigger functions. So f of x is equal to x squared plus 3x plus 4 in the numerator, so that's going to be my first function, and then x squared minus 1 in the denominator, and that's going to be my second function. Okay, let's go ahead and work out these derivatives. So the derivative of f of x is equal to 2x plus 3. And then our derivative of g of x is going to be 2x minus 0, but I'm not going to write that out. So let's go ahead and find the actual derivative. F prime of x is going to equal, start at the bottom, work our way to the top, and we subtract from the top, working our way to the bottom. And then in our denominator, it's going to be our bottom function, x squared minus 1, all squared. So I'm going to go ahead and FOIL out this numerator a bit. Alrighty, so I'm going to go ahead and combine like terms here. I didn't multiply that one out because it looks pretty enough. But this whole thing is equal to my derivative. So we have f prime of x is equal to this quotient. So notice right here, I did have to distribute this minus sign. So all three of these became minuses. Make sure we don't forget to distribute the minus sign because that always makes a big difference. Alrighty, so we have one more problem. We have f of x is equal to e to the negative x over the square root of x. And actually, I'm going to rewrite this in two different ways. So first, that e to the x can go to the denominator since it has a negative exponent. Square root of x can be rewritten as x to the power of 1/2. That way I can see power rule a bit nicer. And now I also have a quotient. So e to the x is my bottom function, x to the 1/2 is my top function. Alrighty, let's go ahead and find these derivatives. So the derivative of f of x is going to be 1/2 x to the negative 1/2. I just subtracted 1 from the exponent, so 1/2 minus 1 is negative 1/2. And now let's look at our e to the x, and we know the derivative of e to the x is just going to be itself, e to the x. So let's go ahead and write out this derivative. F prime of x is going to be equal to low to high minus high to low. And all of this is going to be divided by the denominator, so e to the power of x squared. So first thing I notice here is that in the numerator, they both have an e to the power of x. So I can go ahead and pull that out, which tells me one of those e to the x's is going to cancel out. So I'm no longer going to have this squared. I'm going to go ahead and clean this up a little bit. And so in the numerator, I can rewrite that as 1 over 2 times the square root of x. So that x has a negative 1/2. I can bring it to the denominator, which is then multiplied by the 2, and then I rewrote it with the square root. And then all of this minus the square root of x, all over e to the x. I feel like you can always go further to simplify functions. This would be okay in my book. I mean, like even the part above it would be okay in my book, but that's where I'm going to stop for this derivative. But that's all I have for us today. If you enjoyed this video, please leave a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.